So today, Dijkstra algorithm will be our topic. The steps we will be performing for understanding this topic will be: first, introduction. After the introduction part, we will look at the algorithm that we are using and also the time and space complexity at last. Firstly, in introduction, uh, why Dijkstra algorithm is used is the main question. Dijkstra algorithm is used to find single source shortest path. If this is our source and we have to find the path to the destination, then we are going to go through the shortest path. This shortest path is means in every step we are updating our shortest path. We can think it as our greedy approach, and this is mainly used in network packets as well as this is used for mapping the road mapping the distance for the apps such as Uber, etc. So let us now look at the algorithm. Uh, Let us consider this tree, this graph as of our example. Um, Firstly, we should know what is meant by our the source node as well as the neighbor node. The source node is the node from which we are starting. Here A is our source node and the neighbor node will be just directly adjacent to it, that is B and C. The point here to be note that Dijkstra algorithm will only work for directed as well as weighted graph, and this weight should not be negative. And here we will use the concept of priority queue. Means let us take minimum priority queue. Let us take all the nodes A, B, C, D, and E. Initially, the distance of all nodes will be infinite except the source node. That is, B will be infinite, C will be infinite, D as well as E will be infinite. And we will calculating distance from A towards its neighbor. Means let us name it as our reference node. A is our reference node and we will be calculating the distance from this reference node. Now the distance of B is 4, which is less than this infinite. So the new obtained distance is less than the previous obtained distance, so the distance uh, uh, will be updated. Let us make this distance as 4, and similar for C case, the distance here is now 2, which is less than this infinite, so the distance will be 2. For the D part, no direct path exists from A, we have to go from B or C, so the distance will be infinite only. Similar for E, no direct path exists from A. Now, as the nodes are stored and their distance are stored in the priority queue, the priority queue will look at the smallest distance, that is seed distance, and this will be considered for next evolution. So let us take it out, A and C. Now this point will be our fixed point. When we look for the distance from A to B, it will be 4, and from C to B no direct path exists, so the distance will be 4 as it is. uh, the C's distance will be 2, and for D path the path exists from C, that is this path, 2 plus 8, so this will become 10, which is less than previous value, and also from C to E path a path exists, and the total value of 12. So we will update this path as well. Now again, in priority queue, the smallest path will be considered. C is not in priority queue. Only the nodes B, D, and E are currently in the priority queue. From this, the smallest distance is of this 4. So this will be considered for reference of next path. A, B, and C are now considered. So let us write all this thing. 4, 2. These are now fixed. Let us check the distance of D from A, B, and C points. We can see two paths. One is going from here and the other is going from here. This path has value of 10 total, and this has total weight of 9, and this ninth weight is less than the previous value, so it will be updated. For 8 for E, we can see this path exists, and from B this path exists. So this previous path only has the minimum distance, so it will be written as 12 as it is. Now only D and E are present in priority queue, and from this D and E, 9 is the minimum value, so we will consider this 9 for our next step, for the D node for our next step. So A, B, C, and D. Now the distance of this 4, 2, and 9 will be fixed. Distance of E, we can go to E from this path, from this path, as well as from this path, as D is also considered, and the minimum distance will be less 9, and this is 4 plus 9 plus 2, that is 11, which is less than the previous value, so 11 will be kept here. Now we can see that our priority queue has now been emptied, and no further nodes are there for evaluation, so our algorithm will end here, and we have got the minimum distance of B, C, D, and E from A, and as we have discussed earlier, the source node distance will be 0 only, because a distance of A from A will always leads to 0. Now let us look at the source code of this algorithm. Source code. Let us call this function as Dijkstra. We will be taking values of n nodes that will be given. Let us call it as V. Also we will be given the adjacency graph, means this graph will look like, for this example this graph will look like A will be adjacent to B, and B will be adjacent to C and D, and like that, means here the node is present and here the values are their neighbor nodes which are directly connected. So this graph will be given in our question only, and we will also given the source. Let us write it in short form. Source. um, A. For this example, our source is A. Now first thing we will do is we will declare the priority queue, and after declaring the priority queue we can also declare the distance array. Distance array will be float of infinite for all v, and distance of source, that is A, will be initially 0, and we will put distance, and after that we will put the source node in the priority queue. The point to be remembered is that this source node, this is the first value of the priority queue, and that is distance, and the second value is of node. So priority queue will first check this first value and will give maximum priority for the node having the least value of this distance, and after that we can run the loop, while priority queue exists. Means till then our loop will be going on. We will extract the topmost priority elements. Firstly, the distance will be extracted. For first iteration, this distance will be 0, distance of current node, and also current node equals to pq dot pop, and after that we will go through the adjacency list of this current node. In this example, the adjacent nodes to A are B and C, so we will go through them. We will take for loop for adjacent node. Also the graph will also consist of the edges, means distance of A to B is 4, so B comma 4, this will be the pair stored in the graph. Let me write it correctly, B comma 4 and also C comma 2. In this from bth node we can see the distance of neighbor node are C and D. Likewise for all nodes these two things will be existing. So for adjacent node comma adjacent node distance, we will be traversing in graph of current node. Now we will check if firstly initialize new distance as current distance of current node, distance of current node plus adjacent node distance. If this new distance is less than distance of adjacent node, we will now update this adjacent node distance as new distance only, and we'll put this in our priority queue. The point to note here is that we will first put the distance, and after that we will put the node value. The distance is now new distance, and the node that we will be putting is adjacent node, and this graph will continue for that time only. And lastly we will return the distance array. So now let us look at the time complexity. The time complexity for this will be O of V plus E into log V. Now this log V came because priority queue for insertion and deletion take this much of time, and this V plus E came for every V we are looking for its adjacent edges, so from there this term came, and from priority queue insertion this term came. And space complexity will be big O of V plus E, as we are storing the distance and the adjacency list. So that is it. Thank you.